So we have seen in the morning. Now I hope that it is visible. There should not be any lag much. I have updated my system also, restarted it. That's why. Okay. So why the language modeling we are using it? As we have said that like for POS tagging, for parsing, for recognizing the correct word sequence in the sentence, and generating the sentences, text classification, question answering, and speech recognition, language translation, and for reasoning. For all of these purposes, we use language modeling. And as we said that like a statistical model uh, includes like the some of the grammars for natural language processing, uh, and like maybe like to resolve the ambiguities. Okay, to resolve the words, like words having multiple meanings, and for idioms, use of non-standard English, and because two sentences carry the meaning. And like another way is using the probabilistic model, which we derive from the corpus. As I said you is that in conventional natural language processing we use either Penn tree bank corpus or like Brown University corpus, right? Brown corpus. So how do we assign probability? If you see, why to assign probability to a sentence? Now let us see like for spelling correction. The example is spelling
Hello, sir.
correction here.
Sir, are you on Y statistical model for NL?
Why to assign probability to a sentence?
We
No,
are
sir.
seeing
On
Y
statistical
statistical
model.
model for NL, sir.
Okay, now we are on Y to assign probability.
Okay, maybe like a small latency is there. That problem. Is there anybody who is getting like whatever I am speaking? I just wanted to know because like whether fault is from my side or like from other side. That's why. Is there anybody who is syncing with my uh, the slides and voice? For example, just now I have just slided and it's like gone to the next slide, like why to assign probability of a sentence and to suggesting the next word. Again, I'm just coming back once. Is there anybody who is syncing with me? If at least two, three are syncing, it means that like the others are having some latency. Some latency problems may be there. That's why. Anyway, why to assign probability to a sentence? Okay. Is it visible now, everyone?
Yes, sir.
Yes.
Okay. Then we'll go bit very slowly. Then in that case, we have to go very slowly. Let us see this. Okay. Now the first one we are seeing is that the example of a correction or spelling correction. See, it is given the the office is about 15 minutes. Uh, See, there is a typo here. The office is about 15 minutes from my house. It is written. Okay, suppose a sentence is given there. Now, how we can use a probabilistic language model to eliminate, or maybe like what we can see that correct this particular hello, hello, hello. Yes, any problem? Okay, fine. So
Sir,
yes, yes.
what does that symbol signify? Double greater than sign. Is that just an arrow pointing?
No, it is stating that like see the probability of, see, now you have a sentence. For example, you have a sentence about 15 minutes from, right? See, first you see the top sentence. The office is about 15. We have to write it something, okay, from my house. And here we understand that like it is written minutes, okay, or minuets. It is written like this. So what we have to see is that this red written like minuets or minutes here, please see here that like can we replace this word with any other word? So if you see here, see about 15 minutes. See here it is given about 15 minutes from. The probability of a sentence having about 15 minutes from is greater. Okay, this is very greater. Okay, or greater than the probability of a sentence having about 15 minutes from. This is the meaning what I intend to convey. Are you getting me? Are you getting me?
Yes, sir.
Yes.
Yes, sir.
Okay. Fine. Now, similarly, if it is given like why to assign probability to a sentence here, if you see that I am moving to the next slide. If you see here, to suggest the next word in the sequence, like see, suppose in the Google you are just typing it, which is the best. So what would be the most probable or the best word that is suitable? Okay, so which is the best phone, or which is the best game in the world, or which is the best hair straightener, or which is the best country in the world, or which is the best car in the world, or which is the best game, or which is the best network. Okay, so what I mean to say here is like it to suggest the next word. If probabilities are assigned, so it means that the word that comes first, okay, which is the best phone, maybe like more of people, okay, many people have typed the question which is the best phone. That's why maybe like it is considering like among all the searches there is a high probability that the next word may be phone. Okay, then followed by the game in the world, followed by hair straightener, followed by country in the world, followed by car in the world, followed by game, and followed by network in India. These are the few top probabilities for the sentences which is the best. Okay, which is the best. Similarly, if when you are speaking something, okay, in terms of speech recognition, okay, if you take into consideration a speech, somebody is speaking. Okay, now here also we can say that the probabilities will play a bigger role. Now, as I said you that homonyms, earlier I have said you some homonyms like that. This combination of homonyms, or maybe like combination of few words, the homonyms also comes into picture with respect to the combination of words, right? Or near homophones, near homonyms. Now you see here in the speech recognition example, if you see, suppose somebody says that recognize speech, huh? Recognize speech. Now it means to say that like yes, the probability of recognized speech is so greater than, or it is greater than the probability of recognize speech. Recognize speech, right? You know, you understand that like these two are spelled together almost the same, recognize speech or recognize speech. Similarly, you see the sentence below, probability of I saw a van. I saw a van. This particular sequence of words, okay, when somebody speaks I saw van, is this, it means that the first part I followed by saw followed by a followed by van is greater than probability of eyes, of, an. Okay. Now the next sentence also you see here, call my nurse. Call my nurse. Now you see here the next sentence which gives us a similar combination of homonym. Okay, call my nurse. My nurse. Call my nurse. It means that the probability of call my nurse is greater than the probability of coal miners. Okay, coal miners here. Now similarly you see here, probability of no idea. No idea. is greater than the probability of no idea. I hope you understand. Okay, you are getting me what I am trying to convey to you all, right? Why we are assigning the probability basically for a set of or a group of sentences, or probably for group of words. Okay, why we should assign probability to a word or group of words or to a sentence. I hope you're getting me. Yes, understood here?
Yes, sir.
Up to here?
Yes, sir.
Fine.
Yes.
So similarly, in the concept of a machine translation, here also when the probability comes into rescue. Okay. Suppose I say that oh, bada ladka. Okay, bada ladka. Bada ladka means it. What do you mean by bada here? Maybe like a tall or a large. What should we mean by him? Okay, bada admi, tall admi, or a large like a large admi, tall man or a large man. Of course, we can use the word. There is a word called lamba or bada. This type of things we can use it properly. But in the context, maybe like what should we use it in the process of language translation? In some language, maybe like a tall and large gives. There may be a word which may reflect to tall and large. So similarly, in Hindi also, if you can say that bada wala, chota wala means in the sense like bada wala means it means that like um, taking into consideration, it may come into in some context it may come as a tall, or it may in some context it may come as large. But when it is written, like when it is translated, written and translated in some other language, what should be the possible or the best set of words that need to be taken into consideration? So tall man is greater than large man, right? Like for example, I say again like go to my home, go to my house. Huh? Huh? I am at my house, I am at my home. So which sentence should be given more probability? Similarly, there is another sentence also given here: high wind tonight. Instead of high, maybe like a large wind, or instead of large wind tonight, maybe like the best word here for large, maybe like a high wind. That would be the best possible for translation, right? So this is the reason why we are trying to use, or like maybe like you must have understood by now the reason behind using the probability to words or some group of words or to a sentence. So the main goal of this statistical language, when you take it, is to compute the probability of a sentence S or a sequence of words, right? It means that probability of a sentence S, okay, probability of a sentence S equal to probability of W1 followed by W2 followed by W3 followed by W3, W4, W5, W6, like that up to Wn set of words, n words. So it means that W1, word 1, word 2, word 3, word 4, word 5. So probability of that particular sentence is nothing but the probability of a sequence of words. I am a boy. I, okay, I, probability of I, probability of then after I, am, then a boy. I am a boy. So this is the sequence of probability of the sentence S is equal to probability of I am a boy. Okay, this is what is the probability, just trying to calculate. So somewhere a related task is like the probability of an upcoming word. Like earlier we have seen an example of generating a new word or the next word generating. So it can be written, the earlier thing, it can be written probability of S equal to probability of W1, W2, W3, W4, W5 like that up to Wn can be written as, or maybe like up to W5 when you take it. Probability of S equal to probability of W1, 2, 3, 4, 5 can be written as probability of W given W1 followed by W2 followed by W3 followed by W4. It means that what is the probability that this word called a W5 will occur after W1, W2, W3, W4. Okay, after this particular sequence of words, what is the probability that this W5 will occur? So a model basically which computes either of these, either of the above one, probability of a sentence which is equal to probability of the sequence of sentence like W1, W2, W3, W4, W5 like that up to Wn, or the related task as probability of the next word like W5, probability of W5 followed by W1, W2, W4, W5 like that. Okay, this is like the probability of that computes either of these is called a language model. Okay, this is the language model. Now this is with respect to a statistical language model. We are using here probability. Fine. For example, if you see that how do we compute this joint probability, like probability of the best Hindi song of the year. What is the probability of the best Hindi song of the year? How do we calculate probability for this basically? Okay, how do we calculate probability for this? So the intuition is like we need to rely on the chain rule of probability. Okay, what is this chain rule of probability? So you have to recall the conditional probabilities basically. Now, what is this conditional probability? So probability of AB can be given as probability of A into probability of B given A, right? Probability of AB is given as probability of A occurring the first word into probability of occurring the second word given the first word. So if we simply allow more variables, then probability of A, B, C, D means sequence of words. Probability of A followed by B followed by C followed by D can be written as probability of A into means probability of A occurring as the first word into probability of the second word B given A, right, into probability of C, the third word occurring A and B. The first two words are A and B into probability of D, the fourth word occurring given first, second and third word as A, B and C. So if we take this, the chain rule in general is written as probability of x1 followed by x2 followed by x3 like that up to xn is equal to probability of x1 into probability of x2 given x1, means the second word should be x2 given the first word should be x1 into probability of x3, means the third word should be x3 given the first two words should be x1 followed by x2 into like that dot 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 like that you go on. So probability of at last probability of xn given x1 followed by x2 followed by x3 like that up to xn. So this is what we call it as the chain rule. Okay, this is the chain rule. So the chain rule when applied to compute the joint probability of words in a sentence, it can be written as the following. So probability of W1 followed by W2 followed by W3 followed by like that up to Wn can be written as product of probability of Wi given W1, W2, W3, W4 like that up to Wi minus 1. This how we apply the chain rule to compute the joint probability. So for example, what we have seen earlier, the probability of the best Hindi song of the year can be written in this fashion. So as a practical example, if you see here, the probability of the occurring as the first word into probability of best, the next word should be best given the first word should be the second word is best given the first word is the into probability of the third word should be Hindi. What is the probability of occurring Hindi given the first two words are the best? Okay, into probability of what is the probability of occurring the fourth word as song given the first three words are the best Hindi into what is the probability of occurring the fifth word as of given the first four words in a sequence should be the best Hindi song into what is the probability of the sixth word occurring the given the first five words should be the best Hindi song of into what is the probability of occurring the sixth 1 2 3 4 5 6 seventh word as year given the first six words should be in a sequence it should occur as the best Hindi song of the. So I hope that how you are applying the chain rule while computing the joint probability of the words in a sentence. Is it clear till now? Yes?
Yes, sir.
Okay, fine. So how can we compute this probability of year given the best Hindi song of the? Okay, generally how do we compute? It is to be computed in this way, right? Like a count of. So in a corpus, if you give a big corpus, may it be a brown corpus, may it be a Penn tree bank corpus, or may it be any other synthetic data set that you have taken from the training data, it should be the general phenomenon of computing the probability here is that probability or the count of the best Hindi song of the year given by the best Hindi song of the, right? This is how we compute the probability, estimate the probability basically for the the next occurring word, right? This is how we try to do it. But are we really going to do it? Okay, this is the big question mark. Definitely we do not go in that way because of there are too many possible sentences and we require high amount of data. Huge data is required, right? So how do we do then this? How can we go for this method then in that case? So because computational cost will be very high. This is the reason. Okay, please let me. Now that's why what we try to do is that we make we simplify the assumption using Markov assumptions. Okay, here comes Markov assumptions as a rescue. So what is basically Markov assumption? So the probability of year given the best Hindi song of the can be written as definitely. So either what we can try to do is that we can use as bigrams or trigrams or 4 gram, 5 gram, quadgram, pentagram, like that we can 6 gram, 7 gram or n grams, like that we can use it. So if you see the bigrams, okay, the bigrams if you see, so the probability of year given the best Hindi song of the. So if you see, instead of why should I use the complete set here? You're getting me? Why should I make a big computation here? The best Hindi song of the year given by the best Hindi song of the. Why should I give like this? Can I give instead of 2 2? Means definitely we know that year, the word called year comes after the second the, last the, right? The best Hindi song of the. So can we write it? So it the upper one, probability of year given the best Hindi song of the, can be approximately written as, or it is equivalent to probability of year given the. So it means that the word year is occurring after the. It is not bothered about how many words occurred before the, but it is mostly interested about occurring after the. This is what we call it as bigrams. Okay.
Sir,
Yes, please.
how will we differentiate inside the computer if it is the first the or the before year?
See, either first or second or third, or it doesn't matter. But what is the probability that before year occurring, the has occurred? Okay. This is the only thing the computer takes into consideration. Whether it is first, there may be 100 das. Okay. There may be 100 das. But only thing is that the computer thinks. Now, so if you see, how do we compute this one? If you see the second one now. Okay. See the second example with the trigrams. So now suppose for the bigrams, if you see the second example only, for the bigrams, if you see, it should come as like, what is the probability? So probability of the occurring before of, or sorry, after of, right? The probability of the given of, then probability of given song, probability of song given Hindi, probability of Hindi given best, probability of best given the. So this only it calculates about this only. It is not told about position. Here position is not a matter, but it is the sequence is matter. But how many sequence of words you have to take into consideration? Only two sequence of words. Two words in the sequence. Okay. I hope you understand. You got me. If you take trigrams, probability of year given the best Hindi song of the, then it can be written as a trigram. Okay. Probability of year given of the. So of the year, right? Of the year is a trigram, 3 gram. That's it. Okay. Similarly, if you see, like for the Markov assumption, probability of W1 followed by W2 followed by W3 followed by like that up to Wn is equivalent to, okay, product of P of Wi given Wi minus K, okay, I minus K minus 1, like that, K plus 1, sorry, I minus K minus 1, like that up to I minus 1. You have to move on like that. Okay. Now, so we approximate condition probability of each word Wi in the product. That is what we are trying to do it, right? We are trying to approximate the conditional probability of each word Wi in the product. So the simplest case is like the unigram model. What is this unigram model? It means that what is the probability of the word occurring? Only it bothers about the occurring of the word. It does not bother about occurring of any word with some other word combination. It is not at all. So some automatically generated sentences from a unigram model can be given as like that. See, if you see the words below, there is no relation. There may not be any relation between the first word and the second word and the third word and the fourth word, like that. There may not be any relation, right? It simply generates some words, unique, right? Unique words, they are unigram. Single words it generates. Okay. This is what we call it as unigram model. So it is given as probability of W1 followed by W2 followed by W3, like that. It is nothing but simply the probability of, or product of the probabilities of individual words, Wi. This is what is told. Okay, this is unigram model when we see, but unigram model is basically just to check whether that words are available in that particular sentence or not. But this will not help us out. Probably the bigram model will help us out little bit more better than the unigram model. So here in the bigram model or trigram or 4-gram, 5-gram, okay, any gram, n-gram models, we try to put up some probability here or the conditions. Okay, some conditional probability here. So what is that one? Probability of Wi given W1, W2, W3, like that up to I minus 1 can be given as probability of Wi given Wi minus 1. It means that what is the probability of nth word occurring given a n minus 1 word is available. Okay, this is what we are interested in bigrams. So if you see below, maybe like some of the words that are being generated are maybe like there should be some of the little bit of some sort of combination between the word to word. Okay, maybe like if you see the say outside new car parking lot. Okay, maybe outside new car parking lot, lot of the agreement reached. So maybe like this type of combinations may occur like that. This is what we call it as bigram modeling. Similarly, if you can go with maybe like a trigrams, quadgrams, pentagrams, okay, like that you can go up to more 6 gram, 7 gram, 8 gram, or maybe like n gram, what you say. But most of the literature, okay, generally are into, because of the computation, maybe like either bigram, trigram, they fix it with that one. More grams, 4-gram, 5-gram and all, generally it is not taken into consideration mostly. Okay, so we can extend this model, that unigram to bigram, this conditional probability of probability model, the bigram model, to trigrams, 4 grams, 5 grams, like that. We can extend this one. So in general, this seems to be an inefficient model of language, because the main reason is that language has long distance dependencies, right? If why you see that there is a long distance dependency, the example also it is given here. Okay, the computer which I had just put in the machine room on the 5th floor crashed. So you see that there is a dependency from computer and crashed, right? What crashed? The computer crashed. It means that the dependency of this word, where it is like a floor crashed. No, it is not floor which has crashed. It is the computer which has crashed, right? So it means that there is a language long distance dependency from word to word. It doesn't mean that there is always a dependency from first word to second word to third word to fourth word. Okay, there may be possibilities of, so if you use bigram, trigram, 3-gram, 4-gram, okay, like this, any other gram models, maybe like it depends upon which distance of the word that it occurs, so that you to identify the dependency. Sometimes we may lose the dependency, but we can often get anyway with n-gram models. If you are using n grams, and where n is the number of places where the dependency is found out. So how to estimate the n-gram probability from the corpus, basically? So earlier, as we have seen, we try to use the maximum likelihood estimate. Okay, maximum likelihood estimate. What is this maximum likelihood estimate? So it is like the probability of Wi given Wi minus 1 is equal to count of Wi minus 1 followed by Wi given the count of Wi minus 1. This is how you try to get the maximum likelihood estimate, or the probability, estimating the bigram probabilities. If it is trigram probabilities, wi followed given wi minus 1, wi minus 2, oh, sorry, wi minus 2, wi minus 1. Okay, that should be, it is equal to the count of wi minus 2, wi minus 1 and wi given count of wi minus 2 and wi minus 1. Okay, it should be like, for example, let's give a small example here. The sentence which is given, okay, the sentence which is given is, suppose in small coding, okay, uh, language, suppose it is given that start of the sentence s and end of the sentence slash s, maybe like some same as that you write it in an HTML code. For example, I am Sam, Sam, I am, and I do not like green eggs and ham. So you just please try to take that this as the data set. For example, this is the data set. How do you compute the bigram estimate? Okay, how do we compute the bigram estimate? So please check here now. So probability of I given as this first sentence means the starting of the sentence. It means that after start of the sentence symbol, then I occurs. So what is that one? Out of. So how do you compute the probability here? You see here, out of 3 sentences, 2 sentences start with I, right? 2 sentences start with I. This is what? 2 divided by 3, that is 0.67. This is what is the probability or the estimate. Probability of I given start of the sentence symbol is, so 2 times after starting symbol I occurred, right? 2 divided by 3 sentence. In 3 sentences, 2 times it has occurred. So 2 divided by 3 equal to 0.67. Okay. If you see the next one, probability of Sam given the starting of the sentence. How many times it has occurred out of these 3 sentences? You are trying to use the above formula, okay? The green colored one. Probability of Wi given Wi minus 1 equal to count of Wi minus 1 followed by Wi, okay? Wi uh, uh, by count of Wi minus 1. Okay, this is the thing that you have to take into consideration. That is the formula that you are using it. So if you see the next example here, probability of am given I. What is the probability of the word occurring am given I? Okay, so it is equal to 2 divided by 3. 2 divided by 3 again 0.67. So how many times am occurred after I? So I am, 2 times it has occurred, right? You see here, this may be an example. Earlier you have asked, it is not bothering about the position. See, in the first sentence, I am. In the second sentence, if you see, Sam, I am. It is not bothered about first like first and second, or second and third. Okay, it's not bothering about that one. Now the third one is
Sir,
yes, please.
suppose in one of the sentences, just hypothetically, if it was something like I am Sam, I am, then what would have been the probability? Can you just
Okay,
check?
then because in a single sentence, if it occurs, okay, if a single sentence, in a single sentence it is occurring I am, it will be taken into consideration as one only, because here we are trying to take it here as like a two, okay, or maybe like a individual sentence. You see here, the example will come, okay. Here you see, next one I am just giving it, probability of the end of the sentence given as Sam, SAM. Sam given as end of the sentence. What is that? How many times Sam occurred? Okay, Sam, in how many sentence as the Sam occurred? In how many sentences? In 2 of these sentences, Sam occurred. Out of that one, how many times end of the sentence it is there? Only once. 1 divided by 2, that is equal to 0.5. Now you see here, what is the probability of Sam given am? Am. How many times am occurred? 2 times. First and second sentence. And how many times Sam occurred after am? In first sentence only it occurred. Okay. And probability of do given I. Okay. I, how many times it has occurred? I, in 3 sentences it has occurred. And out of that one, how many times it occurred? Like how many times it has occurred? Do. I do. I do. In the third sentence only it has occurred. 0.33. Now, if you see, I am Sam, I am. That was your question, right? I am Sam, I am.
Yes, sir.
Yes? Okay. I am Sam, I am. So, if you are taking this, now the thing is that it completely depends upon what language model you are trying to take it. If you are considering, so basically with respect to the sentence, if you are considering, but generally we do not consider with respect to the sentences. With reference, see it depends upon like what is the sequence of length that you are trying to take into consideration. Suppose I am considering only bigram, then I am in a single sentence when it occurs also I have to take it as 2 times it has occurred. I am Sam, I am. Okay. And I am again it occurred. So out again suppose in the third sentence also I am is there. Though then it have to take it out of 4 times where I am occurred or I occurred, or then how probability of, so you are just simply giving it is, you need to simply calculate it as am given I. Getting me? Am given I. Let me see. Uh, where is this writing tools and all? It is I have made it, but it should generally come. Let me see. Why I am not getting the writing tools? Okay, escape it and write it. Can you anybody help me out? The writing tools. Insert. Or editing tools. Some writing it out something. So I can be able to. Okay, I will do one thing then. Yes, please. I'm not able to hear you. Yes, please. Just let me write it then like this. Okay. In Paint, I am writing it. Okay, please.
Notepad. You can
See, like probability of you are trying to give is it visible? Not. I have opened this Paint. Is it fine?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. Given I. So this you need to calculate it. So how many times it has occurred? So I am giving it here like starting of the sentence. Okay, the starting of the sentence. I, okay, I am Sam. I am. Even with respect to consider this is the only data set. So even consider this is the only data set. Then am given I. So how many times I occurred? I 2 times. This is also I, this is also I, right? 2 times it has occurred. And how many times am occurred? Am,
2 times.
I followed by am, I followed by am. So 2 times it has occurred. So it becomes 1. Given that, like in some other sentences and all, if it is given, okay, like here it is given, I am Sam, I am, then Sam, I am. So and another places it is not given. So in that case, so it depends how many, it depends upon how many times it has occurred. Okay, I hope you got me. Are you clear? Is it clear with you?
Yes, sir.
Okay, fine.
Yes, sir.
Okay. Hmm. Actually, yes, yes, it is here only. Okay, sorry. It is here. Pen. Okay. So here, when you are trying to make it like I am Sam. Okay, I am Sam. Again, suppose you are trying to insert here like I am. I am. Okay, I am. So the probability gets changed now. Now the probability gets changed. I am very this is what you are trying to do it like I followed by I followed by am. So this is now it means that how many times it has occurred. I followed by am, I followed by am, I followed by am. Then in that case, in this case it is 3 by 3. So it is equal to 1. You need to get it 1. Okay. Now, a real world data set, if you see, this is the Reuters data set, maybe like the data set that is taken into consideration for computing the different probabilities. So it is a collection of documents that appeared in Reuters Newswire in 1987. Okay, and it is majorly used for multi-class classification of documents. The total number of classes are something around 90. Okay, please see that this is 90 classes, and the data set contains basically 54,716 sentences in the version that is included in analytical library of Python, and the size of the vocabulary is 41,600 words. Okay, fine. Now, some of the examples of this Reuters dataset sentences are these are the sentences that is given, and we will see about the computing this and all maybe like in our next class. Okay, 8:13 it is. So I'm just winding out right now. Tomorrow we shall continue. Okay, we'll continue stating like how bigrams are computed, then other things how the computations are done, that one we'll see it. Okay, fine. Any clarification till now?
Yes, sir. Sir, can you please go back to the previous slide?
Which slide number?
Sir, where we were to calculate the probabilities.
Yes, I am here now. Hmm. Yes,
I
please.
can't see. Yes, sir. Sir, here, if I am Sam, I am had been the only data set, and we were to calculate the probability with respect to sentence. Then, sir, the
No, it is
probability
not.
had been same,
It is
right?
not. It is not with respect to sentence. It is with respect to the occurrence. How many times it has occurred?
Okay, sir. So,
Yes, please. So maybe like please, some
so
people are
then,
getting confused. It is not because of the number of sentences. If you see number of sentences means, then in that case here the second and the down line. Okay, if you see the down line, I'm just laser pointing it. See this and this, it should be divided by 3, but it is not there like that. It depends upon the how many times it occurred. Okay, how many? Sam followed by end of the sentence. How many times it
okay,
occurred? I am followed by Sam. How many times it occurred? Okay, so this is the thing. Okay. Mm.
okay, sir.
Yes. Any other clarifications? Any other doubts, please?
So, are we expected to decide upon the in means